Right. I'm going to talk about the difference of squares. This is just a special case of quadratics. So normally quadratics are in the form y equals ax squared plus bx plus c. But this is not really what makes a quadratic a quadratic. What makes a quadratic is just this x squared term. And as long as it has that, it's a quadratic. So we've already seen, we've already factored things like this. Y equals ax squared plus bx. When there's no c, they're actually pretty easy to factor. So for example, you have y equals 5x squared plus 7x. And all you would do to factor this is pull out the x. 5x plus 7. And then if we wanted to find the zeros, we know that 1 0 is always going to be 0. So x is always going to equal 0 or something else. And that something else, in this case, would be negative 7/5. But doesn't really matter. This is what we've done before. Okay, this is kind of sometimes you'll have one like this where you can pull out more than just the x, and you should. Let's do minus. So if I had 6x squared minus 3x, that's still a quadratic. It would still be a parabola, right? I can still find zeros for this. And so the way that I would factor this is to pull out the greatest common factor, 3x. And then I have 2x minus 1. This first factor is still going to be 0, right? When does 3x equal 0?
X is 0.
Yeah, if x is 0. So the 3 doesn't really change anything here. X would be 0, or in this case, 1/2. So today we're going to look at another form. What if instead of getting rid of that c term, we get rid of this middle term? And these are slightly trickier, but once you start to see this pattern, you're going to love these as much as I do. So what if I have ax squared and c, and I have nothing in between? Now, in order for this to work, I have to have a minus sign in here. And if we have time, we'll look at why it has to be a minus. We can kind of prove that. But I don't know if we will. So let's just start out with this. If I had something like y equals, let's just keep a as 1 for now, x squared minus 9. How would I factor that?
Find the square root of 9.
Okay, so right now I want to just kind of walk you through the steps in a way that you should kind of know how to do them, but it might not seem obvious. So I'm going to put in my x term. I'm going to put that x term in there. It's 0x. Right? Would everyone agree that this is the same thing as this? 0x is just 0, so I'm not really adding anything. It's just a different way of looking at this. And then I'm going to think about this as, okay, I need factors of 9 whose difference is 0. And this is why it has to be negative 9, because there's no way that I would have factors of a positive number that add up to 0. That can't happen. So the only factors that are going to add up to 0 are the same number, right? So this is going to work best when this last number here is what? Yeah, perfect square, when it has a simple square root like 3. So if I rearrange this, x plus 3 and x minus 3, I would have the factored form of this. And because of this square root thing that happens, this having a perfect square, that's why this is called a difference of squares. The difference because it has to be minus. And then the squares because this works best when you have a perfect square. Is x squared a perfect square? Yeah, right? What's the square root of x squared? X. So x squared is a perfect square as well. And so we have here the difference minus of two squares, x squared. And this is the factored form of it. The square root of the first one plus the square root of the second one, and then the square root of the first one minus the square root of the second one. And let's just prove that this is right. So let's FOIL this. X times x is x squared. X times negative 3 is minus 3x. Wait a second. I thought we weren't going to have an x term. Oh yeah, because the next one is plus 3x. Minus 3x plus 3x is going to cross out. It's going to be 0x. And then we have 3 times negative 3, which is minus 9. And so we're left with just x squared. And that is the difference of two squares. Luckily I tripped off camera, so no one will ever know. Alright. So I want to expand this a little bit.
What do you do when you have x squared minus 9?
Yeah, so if we have something like this, let's just do a simple example again. What if I have x squared minus 25? What's my factored form of that going to be? Based on what we just learned, I'm just going to take the square root of the first one, so x, plus the square root of the second one, times square root of the first one minus square root of the second one. And then you're done. That's it. Right? So these can be really fast once you've learned this pattern. Yeah?
What if it's not a perfect square?
Yeah, so that's, I don't want to go there quite yet, but we will get to that.
Okay. And if it says a plus sign, would you just say not solvable?
Yeah, if it says, if you had x squared plus 25, this is not factorable. Which means it's a parabola, it just means that it doesn't ever cross the x-axis. So it would be like that or something. Okay. What if I had this though? Y equals 4x squared minus 36. What are my factors? Okay, actually, so if we were finding the zeros, we could divide by 4. And we could pull out the 4, which actually is probably the best thing to do here. So we'd have 4 times x squared minus 9, which would be 4, and I'm going to put this one in parentheses. You don't really need to do that. Times, what are the factors of this? X plus 3 and x minus 3. Right?
Wouldn't you be able to do like 2x squared plus 3?
Yeah, so you could also do that. Let's look at another example. So in this one, this is the correct way to do this one. This, you would want to do it this way. Pull out the 4. But what if I had one like this? Y equals 4x squared minus 25. Now there's nothing that I can pull out. So I think Emily was onto this. We could just do the square root of this first one, 2x, plus the square root of the second one, square root of the first minus. So because 4x squared is still a perfect square, this works out pretty nicely. We just have 2x plus 5 and 2x minus 5.
But you prefer it the other way?
This one, there's no other way to do it, right? But you should always look to see if you can pull something out. And if you can, pull it out. So if there's a greatest common factor, that's always your first step in any factoring problem. Okay, and then there's also the case where we don't actually have perfect squares. So what if we had x squared minus 10? Yeah, it's still going to factor the same way, but it's just not going to be very nice looking. It's going to be the square root of 10. Right? That's just, I mean, it's not quite as clean as when we have perfect squares. But you can still do this. That's done. It's as simplified as you're going to get. It's correct. Be careful though, if I gave you something like this, y equals x squared minus 72, right? You would factor this the same way. X plus the square root of 72, x minus the square root of 72. But this is not simplified. Why not? Yeah, how can we simplify the square root of 72? A 9 and an 8, or 36. Yeah, I would go straight for the 36 if you see it. The 9 and the 8 would eventually be there too. So we have the square root of 36 times 2, which is just going to be 6 square roots of 2. And the same thing is going to happen in the second one. 6 square roots of 2. So this is right, it's just not simplified, and so you would lose points for that, right? This is simplified, and that's the answer that we want. So it's a pretty simple pattern, right? I mean, x plus the square root of the second one, x minus the square root. But don't forget about all these other factors, right? If you can pull out a greatest common factor, you still need to do that. If it's not a perfect square, you can still use this pattern. But make sure you get your square root